In today's lesson, we'll be focusing on simple and compound interest. These two concepts are basically taught back in year 10, and we're just doing a revision of it today before doing any kind of harder type of questions in year 12. So simple interest. What you got to remember for this one is it's only paid on the principal, and simple interest is given the same amount every single time period. So let's say every year you get an extra $200, that kind of thing. So the formula can be known by I is equal to PRN. You've done that before. So P, remember, is the principal or the amount of money that you invest. R is the rate of interest, and N is the number of time periods. And this ranges from, per year, months, weeks, whatever. Okay? So, question 1. Find the amount of simple interest earned if $5,000 is invested at 7% per annum for 2 years. So what we're going to do here is we'll use our formula I is equal to PRN. So this will be I is equal to $5,000 times R, which is 7%, okay? And I want you to write this as a decimal rather than a percentage. So I want you to write down this as 0.07, okay? Then times it by 2 years, okay? So if I do that on the calculator, I'll get $700. So just a reminder that this means that each 2 years, okay, I'll get $700 as interest altogether. Right, now, moving on. Find the amount of simple interest if earned if $2,000 is invested at 4% per month for 3 months. So with this type of question, okay, what happens is that it's 4% per month, okay, that is given by the bank for 3 months. Because these two are the same duration, okay, do not divide this by 12 because it says per month or something like that, okay? Usually if questions say 4% per annum, and then this is in months, you divide this by 12, okay? But this time you don't. So your interest is going to be $2,000, which is the principal, times by the rate, which is 4%, and that's 0.04. So we're getting 0.04 of this, okay? And then we're going to multiply that by 3 months, right? So this is the interest for 1 month. We're going to times that by 3. So 2,000 times 0.04 times 3 gives us a total of $240, okay? And that's our extra money earned, or simple interest earned. Right. Let's look at compound interest now, okay? So with compound interest, the interest is added to the amount invested, so the amount on which interest is calculated changes each period, okay? All right, so that means we're calculating interest on interest, basically, okay? Let's have a look at the formula. So A equals to P bracket 1 plus R to the power of N. So AN here represents the amount of money that the principal would accumulate to or grow to if invested at R% per compounding period, whatever that may be. Usually it's per annum for any of those periods. Okay? So this is interesting because compound interest is always used for current banks. Okay? So if you put money regularly in your bank, or leave money in your bank and let it grow, it's always going to grow by a percentage of what it currently is. Okay? So say, for example, if you had $9,000, okay, that would what would it accumulate to if invested at 8% per annum compound interest for 4 years? So P is 9,000, okay? The rate is going to be 8%, so it's 0.08, and then N is 4 years, okay? So what generally happens, I'm just going to let you know here, is that you'll have $9,000, and you're going to lift this number up by 8%, which means multiply by 108%, or 1.08. And then this amount here turns to like 9720. Okay, I'm just letting you know that, right? 9720. So now, after 1 year, what happens is this amount, whatever it is, 9720, is again, lift it up by 8%. So you multiply by 1.08 again, okay? And then that number there will become 10497.60, okay? And then it's going to multiply it by 1.08 again. So this whole amount here is going to lift up by 8%. But notice how that you're always adding 8% of the previous amount, okay? And the previous amount, like comparing this to this amount has interest on it. So you're getting interest, which is the 8%, on the whole amount here, which includes 2 years worth of interest already there. So each time you're multiplying by 1.08 again and again and again to find out the total amount later, you're actually getting interest on interest. And I want you to remember that again and again and again. So compound interest is always better than simple interest in that respect. Now, if I do this one more time, because I need 4 years worth of it, I have 4 of these, which means that the formula tells me to just put those together. Whoops, should be 1.08, but to the power of 4. Okay? So 9,000 times 1.08 to the power of 4 gives us $12,244.40, okay? And that's by rounding to the nearest 2 decimal places. All right, let's move on. Example 2. Find the amount to the nearest dollar to which $20,000 would accumulate to if invested for 12 months at 0.7% per month compound interest. The thing I want you to pay attention to detail is this right here is 0.7% per month compound interest. So just remember it's per month. And if we look at the duration, it's also in months. So these two agree with each other, okay? Because they're the same. That's good. If it's not the same, then we've got to fix up one of the numbers. So 20,000 is the principal. Your rate, in this case, is 0.7%. But if you divide that by 100, you do get an extra 2 zeros after that decimal, like that. And n is 12. So using our formula, we have 20,000 at the beginning, 1 plus 0.007, but raise that to the power of 12. Okay? So 20,000 times 1 plus 0.007 to the power of 12 in my calculator gives me approximately 21,746 and 21 cents. Okay? That's 2 decimal places. All right. So I put a note here saying that the number of periods, which is this number here, and the interest rate per period must match. So since they're both in months, that's good. But now, if we have a look at example 3, find the amount to which $6,500 would accumulate if invested for 5 years at 0.8% per month compound interest. So see how this is per month, whereas this one here is in years. Okay? You have to make them the same. All right. So let's start off with the fact that we've got P as $6,500. Okay? So I'm going to write that down. Your rate here is going to be this, and keep it as this. Okay? Keep the rate the same. That's 0.008. However, this number here is going to change. So you got to write this in terms of months. So that's 5 times 12, which is 60. Now, A would equal to 6,500 times 1 plus 0.008 to the power of 60 this time. And approximately what this is 10,484.44. Okay? All right. Let's move on. Example 4. $15,000 is invested at 1.5% per quarter compound interest. Find to the nearest dollar the value of the investment at the end of 3 years. So firstly, notice that it is per quarter that we're investing at. And we've got to keep it as this way. The principal in this case is $15,000. Our rate is 1.5%. So if you divide that by 100, it would be 0.015. our end value in this case is 3 years worth of quarters. So every year it's going to be 4 quarters. So you're going to do 3 times 4. So there's 12 quarters of a year in 3 years. So now proceeding on to the formula, we write the same thing again as before. Okay, so use the correct P, R, and N values, put it in, and approximately what this will generate is 70,934.27. Okay, right. Let's have a look at our next question here. So $10,000 is deposited into a bank account and earns 5.25% per annum interest compounded annually. How much to the nearest dollar is in the account at the end of 7 years, just after the final interest have been paid? Okay, so we've got $10,000 deposited into a bank. So that's our principal. There's our rate annually, and it wants us to find out how much it is at the end of 7 years. So let's just write that down. Now, this as a rate divided by 100 will be 0.0525. And because this is per annum, that's 7 years, raise it to the power of 7. Approximately, what that gives us to 2 decimal places is 40,307.20. Right, let's do the same thing again as before. Find the amount to which $6,000 accumulates to if invested for 3 years, compounded quarterly at 2% per quarter. So notice how this is 2% per quarter. So you've got to follow this duration. 3 years worth of quarters, remember, is 3 times 4, which is 12. So we're going to have $6,000 to start off with. We're going to increase that by 2% every single quarter. So that's 0.02. And we're going to raise that to 3 years worth of quarters. So that's 3 times 4, which you can basically write as 12. So that will be approximately 7,609.45. Okay, question 3. The new price of a television is $1,200. Assuming it depreciates in value at 15% per annum, find to the nearest dollar the estimated value of the television in 5 years' time. All right, so now we're looking at a question that relates to depreciation. Okay, the formula that is used for depreciation is this formula here. So that relates to having the plus sign in the compound interest formula changed to a minus sign. So in this case, we're finding out A, which starts off with $1,200, okay? And we're going to times that by 1 minus the rate. So that's 0.15 if you convert to 15%. And we're looking at what happens after 5 years. So raise that to the power 5. So approximately what that gives you, after 5 years, this television would depreciate to the amount $532.45. Okay? Now, is investing at 8% per annum for a year the same as investing at 2% per quarter for a year? Let's have a think about it. Per quarter means 3 months, a quarter of a year, and there's 4 quarters or 4 of these in a year. So people tend to think that 4 times 2% gives me 8%. So yeah, it should be the same. But it doesn't actually work that way. Okay? So if I have some principal, some amount that I invest in the bank, we don't know what that is, who cares? And then we do 1 plus 0.08 to the power of 1, because this is 8% per year, and this is 1 year's worth of it. This will be the same thing as P multiplied by 1.08. This number is telling me raise P by 8%. Now, if I do the same thing to this condition, okay, what will be that multiplier? That interest factor. 1 plus 0.02 this time for the quarter. Now, how many quarters are there in a year? There will be 4. So if I then do 1.02 to the power 4 my calculator, I will get P times 1.08243216. So although that it's going to round to the same number, if we don't round it, there is actually an extra amount here. So this overall is better. It's going to increase P by 8.243%. Okay? So no, it is not the same. Right, next thing, finding the compound interest. The amount of compound interest earned is the difference between the accumulated amount and the amount originally invested. This is given by the interest equals to the final amount minus the principal. So, for question 1, find the amount of compound interest earned if $8,750 is invested at 6% per annum for 3 years. So let's use our compound interest formula. Okay, we'll put all those numbers in, and this would approximately be, let me just double check, 8750 times 1.06 to the power 3. Okay, so actually that gives me exactly, not approximately, $10,421.39. Okay, just remember this is our total amount now of our investment, but it's asking us for the amount of compound interest earned. So what we've got to do here is we've got to use that formula where we find the interest by subtracting our principal away from our final amount. So our final amount was this number, okay, that's grew to. We started off with this number, so we're going to get this number here subtracted by that number there. And that will get us the difference between the two numbers, which is our extra money paid to us, which is our interest. So if we subtract those numbers, we do get $1,671.39. Okay. Question 2. Let's do the same thing. Find the total amount of interest, once again, earned if $8,000 is invested at 7 years at 0.4% per month compound interest. So the thing I want us to notice here once again is the fact that it is 7 years that we were looking for this investment to grow to, but it is given at a rate of 0.4% compound interest. So we've got to follow this, okay? So 8 equals to 8,000 multiplied by 1 plus that percentage all the time, so don't change that. 0.004, that's what it would be. But we got to find out how many months there are in 7 years. Okay, so always change the duration, and that would be 7 times 12, which is 84. Okay, so 8,000 times 1.004 to the power of 84. I mean, that gives us this number here, 11,187.211 ... the small numbers. And our interest here in this case will be the final value, which is that number I wrote down. Oops, missed that one. 211 ... minus the principal that we had at the beginning, which is 8,000. So subtracting those two numbers gives us 3,187.211 ... So that rounds us, our answer, to 3,187.21 cents. Okay? Okay. Moving on. Question 3. Jess wants to invest $10,000 for 4 years. Her financial institution offers 2 options. Option A, which is interest of 1.6% per quarter compounded quarterly, and option B, 7% per annum simple interest. Which option would give the better return and by how much? Okay, so in this case, we shall look at option A first. Okay, now in this case, we're going to use our formula A is equal to P bracket 1 plus R to the power of N. Okay, now our principal in this case is 10,000. Okay, we're going to multiply this by 1 plus of 1.6% per quarter, which would be 0. 0.016, whoops, yep. And since this is per quarter, okay, how many quarters are there in 4 years? It would be 4 times 4, which is 16, right? And that would give us, let me just double check that, 6. Okay, so that gives us around 12,891.377, okay? So I'll keep that on my calculator. Then for option B, for option B, we're actually just calculating the simple interest. So our formula is given by I is equal to PRN. Okay, so we'll get P, which is 10,000, times the rate, which is 7% or 0.07. But we're going to multiply this for 4 years, since it's 7% per annum, and there's 4 years worth of it. So 10,000 times 0.07 times 4 is 2,800. Okay, so right now what we're going to do is find out how much interest also that option A gave. Okay, because we're going to actually find out both actual amounts, so the amount at the end, or we can find out the interest. We can just find out the interest here by subtracting this number here, our final amount for the investment, minus $10,000. So 12891.377 ... minus 10,000 would give us, okay, I'm just going to approximate it. I mean, all you got to do is remove the 1 there anyway. That would be 2,891.38. Okay. So if we have a look at the difference between these two, okay, which one gives a better return? It will be option A. So option A gives the better return by $91.38. That's it. All right. So let's move on. This question should say question 4A and B, I believe. Sorry about that. Find to the nearest dollar the compound interest earned if $16,000 is invested for 2 years at 0.5% per month. Okay, so these are not the same duration, so I have to change the years to months. But it's talking about compound interest, so I'll use the compound interest formula. I'll start with 16,000. I'll multiply this by 1 plus of that percent written as a decimal. So that's 0.005. Okay. And once I do that, I raise that to the power of how many months this is, which is 24. Right. But if I wanted to do this straight away, I just type it once. My interest is basically just that amount. Okay, I'm going to write A minus P for the final amount, which is this anyway, minus the principal of 16,000. Okay, you can actually do this first if you wanted to. Let me just check what that is. $16,000 times 1.005 to the power 24 minus 16,000. Okay, so what I've got was 2,034.55.6 cents. And that rounds to Okay, or you can write 2034.56 actually, to nearest cent. All right, now, at what rate per annum of simple interest will produce the same results? Okay, so if we want to produce this amount of interest, and we have this formula to play with, well, this number here represents our I value, our interest. We want our principal, which is $16,000, to grow to that amount. Okay, that's for the interest. And we need to find that rate, whereas n is simply 2 years. So we keep it like that. So let's replace those numbers in. I as 2,034.56 cents. Your principal, which is start off with, is 16,000. Okay. So you're going to multiply it by some rate, which we don't know, per annum, times 2 years worth, okay, to give you that rate. Now, whatever number you get in your calculator will be a decimal. This won't be a percentage yet, okay? So this won't be a percent on your calculator, okay? It is a decimal, okay? Or a fraction maybe. So if we divide these two numbers over to the other side, 2034.56 divided by 16,000 divided by 2 gives us 0.006358. Okay. Now, we have to times this by 100 to make this into a percentage. So multiply this by 100, and that will get us 6.358 exactly as a percentage. And then you can round that to 6.4 if you want, or leave it like that. That's okay. All right, so your homework for this section is to do exercise 14C, questions 1 to 19 and 28, and do that after your trials.